Good evening, sir.
Good evening.
Yeah.
We'll wait for a while.
Yeah.
Book is not there, no?
No, book is joined.
No. Okay, but he says he
Yeah,
won't be
yeah,
available.
yeah. Yeah, today he is going to run a marathon. I don't know.
Oh, okay.
How he joined? He joined.
No. His wife, he said he will be recording.
Maybe, yes.
Yeah, that's what he
Today,
has posted in the message, no? In the
yeah,
group.
I saw that. But today marathon.
Okay.
40
Oh,
kilometers he is. 40
how much
kilometers he
kilometer?
said. 40 kilometers will run.
Okay.
Hmm. India, we never do marathon in 40 kilometer.
We'll wait for a while.
Yeah,
Another 3 minutes.
yeah,
Then we'll
sorry,
start.
late. Yeah.
Hello, good morning, good evening.
Good morning, Edu.
Hello,
Hey, hello, Edu, good morning.
hello, Marimoto.
Yeah, good morning. I think Abhijit also is there. Yeah, good evening, Abhijit. I think Ramalingam will join, no?
Okay, good
I think
evening.
he'll join.
Yeah. We'll wait, sir.
Another 2 minutes. Then we'll start.
Okay, nice.
Deixa a mamãe botar a cadeira pra você. Quer sentar aqui do lado ou aqui na frente? Quer sentar aqui? Isso aqui na frente. Eu sou a juiz. Não tem isso. Né? Vai ter dos pastéis. Você quer mais alguma coisa? E essa massa, ela chupa muito tamanho. Essa massa de pastel, ela chupa muito tamanho. Muita gordura. Gorduroso, olha. Quando a gente tentou essa vez e ficou muito gorduroso, ó. Na verdade, precisa de massa da boca. Cadê o meu de chocolate?
Okay. We'll start. I think Basar may not join. I believe he's busy in attending or organizing some international committee on fracture mechanics in Istanbul, the university. That is on 4th, actually. He said it is on 4th. Anyway, he's maybe it's 30 plus.
Means he's at Turkey, no, sir? Turkey.
Turkey. He works in Dubai.
Oh, he's in Dubai. Okay.
In the energy industry, he works, but he doing some PhD in Istanbul University.
Okay. I think we can start now, sir.
Yeah. We'll start now.
Okay.
Let me share the screen. So you're able to see the screen?
Yes, yes.
Slides? Okay, yeah.
Yeah.
So we'll recap quickly whatever I covered last Sunday. We'll see the classification first. And it is basically done to identify, because there are so many components in aircraft structure, how to ensure which structure has to be evaluated from fatigue and damage tolerance point of view. So here, if you have two categories, either it can be safe life evaluation or it can be damage tolerance evaluation. So on the basis of things, main category 4 category has been defined. So this is a new slide I've added just to give examples, most important components or example. And this is what the flow chart describing how to identify category A, B, C, or D. And category A is defined as principal structural element. Both A and B is known as significant structural element or items. So irrespective of classification, from the certification point of view, both the category of A and B, they have to be evaluated from fatigue and damage tolerance point of view. So this is another same thing is reflected in different format to make it the life simpler to remember the things. That is too much complicated, not so many flowchart, but it follows same thing like whatever previously described. And this is a typical structure. Okay, I'm supposed to share what is the, though it was released by FAA way back in 90s or 80s, I think way back 90s in one of the public domain. So where instead of category B, C, they have mentioned PSC and CSC like that. That's just for overview of the main component. They are not got into detail of parts of each component. So this all definition, I've already shared the notes with you people, so I'll not go in detail now. This is also available and categorized by FAA. It is available in FAR also. So now next, again, classification is done based on the single load path or multiple load path, because ultimately whenever damage tolerance is introduced, the idea is how to include detectable crack length as well as threshold inspection and also repeat inspection interval. So with regarding to single load path, it is straightforward. It can be detected when crack grows from an initial flaw to a detectable crack length based on the type of non-destructive inspection. And critical crack length is based on the limit load. Straightforward, we can find out the safe life growth between those two. But in the case of multiple load path, where this says multiple load path structure externally inspectable. So it's like a wing structure combination where stringer is inside the wing, so it's not possible to access the crack growth. So obviously, the crack may start in the stringer, flange of the stringer, and it can fail the stringer, but that doesn't lead to the catastrophic failure of the wing. So crack may also grow in the wing. So obviously, the primary structure which has been failed inside is not able to be detected. Only the crack comes out of the skin, then you have a limited safe crack growth period. So you have another scenario where it is known as multiple load path structure, inspectable after failure of one load path. So where you have a multiple load path combination of park and log, there are two logs instead of one. Obviously, it's not so easily accessible to inspect in situ. So obviously, crack may grow and fail. But once one of the primary element failed, it can be detected during the inspection interval. So that is what we can just say apply between the detectable crack length and primary load path, and next is secondary load path. Now comes the, okay, this is same thing. Another scenario where same wing and stinger combination, but the stinger is instead of G or L angle, it is a inverted T, where you have better options for detecting crack of the primary structure, that is a stinger fronts. So it's a, though it is recommended, but you are putting additional weight. Now, instead of L, that would have been done, but you are unnecessarily including or inserting a T type. But in case some structure will have this type of combination, so we have a better, wider safe crack growth period available between the detectable crack length and critical crack length. So this is one more whatever I have based on the inspection, the way we are able to inspect a single load path or multiple load path. This is more in concise, the table which has not presented last time. Anyway, when I share the entire material, presentation material, this will be in there. So this is very quickly, but it looks very clumsy and compact, but it's nicely can be said. So you have a category A and B. It can be safe life. See, category A and B, no doubt it says as per the FAR requirement, they have to be evaluated from fatigue and damage tolerance point. But also, FAA is liberal or IAJA is liberal to allow category A or B or both can be evaluated in safe life, provided can be demonstrated that it's not possible to have a inspection due to whatever consideration, whether the accessibility is not there, economic point of view, design, not possible to implement the design damage tolerance design philosophy. So still structure category A and B can be done safe life. In that case, you have to go to fatigue life. So here is the path. In category N way, you go to safe life. Obviously, safe life, there is no inspection allowed. So in that case, it is a question of fatigue life based on the cumulative fatigue damage, like SN minus rule. But in the case of say category A and B, then next comes to damage tolerance. So it can be damage tolerance. Also, it can be single load path or it can be multiple load path. So if you consider damage tolerance with single load path, then you can have both inspection required because it is a damage tolerance. Obviously, inspection is required. It is based on your residual strength and crack growth. So which I will be describing down the line. We have already discussed about residual strength and crack growth. Also, we know the basics of the things. So they are the basis for which the category A and B, which is our damage tolerance, but single load path. In the case of category N B, which is a multiple load path, it can be fail safe and may not be fail safe. So fail safe means that you are providing redundancy, parallel load path. One of the load path breaks, obviously other elements should be able to carry the redistributed load. So that is a fail safe. Sometimes it may not be possible. In that case, is not a fail safe. In that case, again, it is based on the inspection. It is again the analysis based on the residual strength and crack growth analysis. But in the case of damage tolerance, category A and B, damage tolerance, multiple load path, and fail safe. So in that case, we have seen the previously 4 cases where you have this is just showing an example of structure inspectable because we have all these 3 categories. Structure inspectable for complete failure of the primary member, structure inspectable for less than 1 complete, that we already described, and structure externally inspectable. So based on the type of component, one can follow. And I'm skipping this column, crack arrest, no crack arrest. That is a very rare case, and the special cases, especially stipend panel, they will have. But most of the cases, it may not be possible to achieve crack arrest. So So based on again inspection, it is based on the reserve strength and crack growth, except your safe life, which is based on the minus road using Asian card. But rest of thing is DT means crack growth. Crack growth means you should have it accessible to inspection. Now coming to selection critical load, so we have seen there are different item can be identified as a potential source for identify. So these are like review of joint areas, review elements. So this is not exhaustive, but majority of them has been covered here. Then next you have an overview of MSG3. So as I mentioned, it's very narrative. So quickly, there's nothing to explain. I will just quickly touch upon the important points. So I have already covered detectable damage and inspection types. Also partly I've done MSG3. Then today I'll be covering non-destructive testing. That's the overview. So as mentioned earlier, it's only additional information to know how this MSG3 maintenance steering group 3 is able to arrive at what should be the detectable crack length based on the general visual inspection or the detailed visual inspection. So these are the main inspection time, general visual inspection, and these are the silent points. Similarly for detail, those are all naked eye or using some special aid like lens, special light and all. And MSG3 is only related to the detectable crack length, nothing to do with non-destructive inspection based on the equipment like eddy current, ultrasonic, magnetic particle, X-ray, so and so forth. So these are the basic six components. Six inspection type that is being used in situ on the aircraft structure as a part of regular inspection. Then we have seen the overview of MSG3. Prior to that, I just defined what is a principal structural element, what is the airworthiness limited items, and significant structural items. And the MSG3 is responsible to arrive at inspection schedule and also the detectable damage that may occur due to accidental damage, environmental damage, or fatigue damage. And since there are so many forms of principal structural element, for easy accessibility and identification, they also give as SSI, structural significant like category A and B. Under each serial number, they will be having PAC 1, 2, 3 based on the same inspection area and all. So this is background already described earlier. And basically, as of now, MSG3 is the latest one from 1981, 80 onwards there, but obviously there are multiple revisions. This is not accessible publicly. This is meant only for airlines and all. But basic has been covered how the MSG started with 1, 2, and 3. The main objective is to increase the efficiency because every time you grounded the aircraft for maintenance, it involves financial consideration and all. So obviously they have to improve the efficiency without compromising safety. Detectable crack length is already defined, and this is based on visual and your hidden. Your detectable crack length is a summation of visual and hidden, and also visual again is based on the basic detectable crack length multiplied by gauge factor, and this is all process involved. There is no say over by anybody else. MSG3 has done the systematic study, and that is applicable to and acceptable to not only the airworthiness agency authorities, and also airlines and customers. and certifying agencies. So this detailed crack length is either one can use that for not only threshold inspection, the first time inspection of that component, also for repeat inspection interval. So you have general visual inspection, detailed visual inspection, special detail inspection, which uses the equipment, special equipment. Both A and B, they are naked eye to be used. And the idea is they will try to formulate detect the crack length based on general visual. If not possible, then they go to next level of detailed visual inspection. If not possible, then they go to special detail inspection. And we have seen that MSC3 only concerned about the detectable crack length, and also how they have defined size L basic based on the viewing rating, congestion rating, size rating, lighting rating, surface rating. Then that has to, after getting those ratings, once the value has to be multiplied with two more factors, gauge factor and gauge factor. And this is the flow chart as already explained. Based on the whether it's inspectional or not. So they have to start with the GBI. Not possible, then go to DBI. If not possible, go to NDI. NDT equipment. There are set of NDT equipment. Again, they'll try to see whether still it will possible to detect the crack, meeting the practicability. See, one can detect if it's detect crack length is too long and there's nothing and is close to the critical crack length, we will not able to schedule any inspection interval. There's no use. In that case, it's required to redesign the component. And the basis on which crack length is included inspection level, like GBI, DBI, then obviously view rating, those are all additional rating which we will do today. Then use gauge factor and edge factor, then add the critical crack length to get the detectable crack length. And this is the flow chart, how the ratings are based on this. Ratings means some numbering is assigned based on this particular ratings. So this is to decide on if GBI is not possible, then go to detailed design. But as mentioned, MSC3 is nothing to do with special detail. It's just separate because that is involved the equipment, probability detection of the equipment. So these are the review questions related to what I covered last Sunday. And see whether questions are simple, understandable. Is that clear? So let's start next slide.
Yes. Okay, sir.
Okay. So now we'll go through, again, these are very narrative. Anyway, you will have the notes with you, but I'll just explain. It's very self-understand. Understand there's nothing to explain that. So viewing rate means it's related to accessibility of that particular component. And please remember, it is only related to general visual inspection and detailed visual inspection, where you don't use any special sensor or equipment. So the ratings are based on the type of accessibility. Whether there's no access, obviously the rating will be 0. Hidden items at distance greater than 3 meters, poor or moderate and good. So this is the definitions of viewing condition. For each they are given the numbering that I will show you in the flow chart in the process how MSC3 used the process to give the rating. So this is related to viewing rating. So when general visual inspection is considered, then the viewing rating should be selected according to the zonal inspection condition. So for the classification or identification of zone of the aircraft, because the aircraft is such a huge, they have to identify some zones that I will tell you in, down the line. For detailed inspection is considered, a viewing rating of 3 is selected. So for GVI, this is a different rating is there. Plus, if it is only meant for detail, obviously it is only 3 will be there. Because for detail, your space is distance should be within 0.5 to 1.5, right? Something is there. We saw the silent feature. Anything more than that is not detailed visual inspection is not applicable. Then comes to the congested rating. So it is divided into 3 conditions depending the number of components and system in the area to be inspected and the complexity of the component. So it can be congested, can be moderate, it can be clear area. So clear area like example external skin area, or congested example is obscured by pipeline. So there are 2 extremes. So in between is a moderate. Whatever inspection level is considered, general, visual, or detailed congestion rating should be selected in accordance with the SSI area, significant structural items. Okay, that has been already classified based on the PSI. So based on that SSI, the rating has to be assigned. Next comes sizing rating. So your general visual inspection requires an assessment based on the size of the zone as per the journal program. Whereas for detailed visual inspection, the size of SSI concerned has to be taken into account. All SSI, you have seen the PSC forms a subset of SSI. So it can have 1 to n number of PSI, but there will be SSI will have a limited PSI and all. For GVI inspection, size of zone is given as a large area, such as a complete skin in the case of fuselage or wing, or it's called medium area for approximately square meter or less. But for detailed inspection size of SSI, there is no question of area. It is related to fitting, whether it's a frame or spars. Medium size fittings to include portions of frames, spars, reefs, and intercostals or stringers. I hope you are aware of these intercostals. Marimutu, you are aware of it?
Yes, sir, but intercostal, I think I could not visualize the component of how it looks. Do you have any images, sir, where it will come?
Right now I don't have, but I can explain you. See, you have a frames interspace, right?
Yeah.
Okay, but once you make a door which may cut across 1 or 2 frames, or at least 1 frame.
Yeah,
no continuity.
Then the surrounding we need to put frames. It's like a hatch.
So you have if this is the door, cargo door, passenger door, whatever may be. So this should have been frame. I'm just giving dotted line because it's behind the skin, and obviously one of the support will be the frame, and another side also you should have a frame.
Yeah.
But middle frame doesn't have any continuity, so they provide interconnection here.
Yeah, that is a hatches, hatch fittings. We
Not
say
hatch. No, not hatches. It is a beam stringer, no.
Only, but hatches, then intercostal is there, sir. Yes. Then I could remember. Okay, but I could recall this because whatever we were
Yeah,
working now, we have that cutout and that frames are discontinued. Around that, to redistribute
you have
that
to
frame loads, yeah, that we are making.
you have to strengthen with the stiffeners,
Yeah, yes, yes,
neighboring stiff.
yes, yes, yes.
Okay. So when it comes to detail thing, the definition is related to fitting,
Mm.
depending the zonal size, which I'll be showing down the line. So here, okay, this is large area, rating is given as 1, medium large is, or large fitting is 2, medium size fitting is 3, and small area or small fitting is 4. Then lightning rating, again, it's based on the surrounding lightning. Sometimes you have to use special light things like torch and mirror. The 3 ratings considered to be associated with the type of inspection involved. Exterior of aircraft in shadow, example landing gear bay without direct light. Then exterior or aircraft in full daylight, inside aircraft with artificial light, and concentrated lighting as required, depending the location. The first 2 ratings or conditions should be used for general visual inspection. Normal cabin light can be used as a necessary. Then obviously concentrated lighting is to be used, detailed visual inspection. That is one of the additional features, silent features of detail 3, where you have to use concentrated light. Then you have a surface rating. Surface condition will vary according to the nature of the paint, presence of sealant or cleanness. 2 ratings are considered as follows. One is called areas or items are liable to be covered in sealant or subjected to excessive grease, oil or dirt contamination. And obviously another is clean area with the removal of sealant. For detailed inspection to be clean area with the removal of sealant, because in detail that's a requirement. Need to be removed, sealant or grease is there due to preparation of surface before inspection. However, the presence of sealant should be included in the determination of hidden crack length, as it will normally not be removed during routine inspection. There are cases where it's not recommended to remove the sealant. In that case, obviously crack coming under the sealant, it will be considered as a hidden crack. Now we have seen all the ratings required for the determination of basic length. Now we will go into how to calculate the detectable crack length, which is known as visual crack length. The crack length, which is can be observed using naked eye. So where you have to have a basic based on the type of rating, gauge factor, and a multiply factor. So this are actually MSC3 has already come out with the process flow and rating and what should be the crack length. So it's nothing to do with the OEM or user or any engineer to evolve or develop a detectable crack length. This is already inbuilt. Unless one uses NDT equipment for which MSG has no say about it, and depending on the type of equipment used, ultrasonic or low frequency current or high frequency current, they will have a probability of detection depending on the resolution of that particular equipment. So that will be already listed along with the equipment. So one has to go by what manufacturer of those NDT equipment provided. But in the case of GB and DBI, all people like authority, air reference authority, OEM, and user, they have to follow this rating. So gauge factor is basically depends on adjustment of material thickness. So the component will have different thickness. And for material thickness less than 5 mm, generally gauge factor is considered as a 1. For material thickness more 5 mm to 10 mm, its gauge factor is 1.25. Anything more than 10 mm, gauge factor is considered as a 1.5. So there's no way it can can be questioned why 1.5, why not 1.2. This has been evolved, so you have to accept as it is. S factor, this is related to adjustment to the S factor. Because the occurrence of crack, whether it is axial damage, environmental corrosion damage, or fatigue damage, depending the thickness of thing and age factor, whether it is in center or edge, that will decide how prominent the crack length can be detected. That's why they have added gauge factor and age factor. For cracks which originate from or terminate at the edge of the component, the age factor is known as 0.5 should be used. If non-edge cracks, the age factor is 1 used. Now we have seen the L basic.
The detectable crack length, if you say it's 1.25 into 1 means that the thickness means a crack length could be 1.2.
No. The rating that I'll show you. I'll give you an example.
Okay.
Depending the viewing, surface condition, lighting, and all, the ratings are there.
Okay.
So based on the rating, that has to be multiplied. I'll show you one example.
Okay, sir.
Then it will get clear. So we have seen L basic, then L visual, then next comes hidden. There are 3 components to determine the detectable crack length. So determination of the hidden crack length is dependent on many factors, including design and anticipated crack direction and presence of sealant. So these are special 3 major cases where you can have a 2-plate joint using countersunk rivet. So obviously you have a hidden length of the total diameter and hidden countersunk hidden LC. So these are the definitions. L0 is the effective length due to the fastener hole. L0 here. So this is the diameter. LC is the length of countersunk, because throughout your fuselage wing, they may use same countersunk. Their geometry diameter, it may vary. So depending on that, and also crack may occur at one end and may occur in both ends. So there's a possibility of this. In that case, so LH is the hidden crack length, and L detectable is effective detectable crack length, and visual detectable crack length, then basic detectable crack length. So in this case, the 3 most important cases, your direction of visual is from the top, this arrow what you see. So when cracks come out from the countersunk, obviously as long as it crosses LC, is a detectable, but it depends on the ability of the technician to see clearly without any ambiguity, without any doubt. So it will be some cutter, and this length is far away from LC, depends on the rating. This is another case. There is no countersunk, but you have a 3-plate joint. Crack may start inside, and it is obviously it's blocking top plate as well as bottom plate. Bottom may not be accessibility there. You have to see the top, because bottom also you cannot see in naked eye. So obviously, in that case, you don't have any other option other than using special NDT equipment, either ultrasonic or eddy current. But as long as visual is considered for this type of component, you have to have this. And of course, in countersunk, you can have both side crack, where hidden is known as L0, diameter of the thing plus 2LC. So effective detectable crack length is used to determine the crack propagation life from its critical length. The effective detectable crack length considered hidden crack length is defined as L visual plus L hidden. So your visual is the detectable crack length and LH is the hidden crack length, which are the definition. And that's all related to the visual detectable crack length based on the naked eye, GVI or DVI, detailed visual inspection. But when it comes to special detail inspection, this is based on your NDT equipment. And the basis for using NDT is to digest detailed crack length, the geometry and materials of the SSI, the probable damage locations. So based on this criteria condition, one can go for using NDT equipment, not a static equipment inspection using the NDT equipment. So this is the type of telling zonal and directed inspection program. Two inspection program used to ensure the integrity of the structure. One is called the zonal program, which is general surveillance. That is adapted as soon as aircraft lands after completing one sortie and before takes up to another destination. And the structural program, which is directed inspection, where you have to use NDT equipment. So general inspection program comprises general visual inspection tasks for each zone of the aircraft in the general surveillance of systems, power plant, and structure for general conditions. And the inspections are specified quoting the relevant zone number, zone description, access, and inspection interval required. So obviously, the way ATA chapter has been used to identify each section without any doubt. Okay, fuselage is 53, wing is 57, then door is 29, like that. Similarly, to identify, because each component will have location will be different for easy accessibility and understanding. So that has been already universally defined, journals of the aircraft and the zones of the. So this is, you can see journal, this is related to the journal inspection program. There are different checks there, not only daily, weekly. Then you have, of course, check A, check 2A, 2B, 2C, and 8C. It goes up to 120 months. And you see here descriptions, all are related to GBI or DBI, nothing to do with NDT equipment. So based on the time interval, there are different zones are checked based on these durations. Okay, shall I go to next? Shall I move to the next slide?
Yes.
So this is a structured program where, based on your crack growth analysis, for each component, one would have arrived what is the threshold inspection. That's the first detected crack length, what number of flight hours, and what is the repeat inspection interval. Those are based on the crack growth analysis for each component. Obviously, each component will have different detectable crack length, different inspection interval, and all. Finally, when they arrive at the exact threshold and inspection interval, based on the minimum of analysis done for each component. So this is where called directed inspection program. So there are used detailed inspection corresponds to detailed visual inspection, and also special detailed inspection using special technique wherever necessary. To take account of the potential source of damage, the following parameters used to determine the inspection threshold and repeat inspection interval. Usually, whoever involved in Airbus work package, they would have given type of damage. If it is a fatigue damage, items affected by gag cycle which are not range dependent. This is ground and ground cycle, but irrespective of range, there is short range or long range, there some damage may occur irrespective of range. And another is fatigue damaged items affected by gag cycle and which are range dependent. So same aircraft is being used for the short distance, another is long non-stop distance. So usually they will specify the inspection, whether it's a GBI or DBI or NDT in terms of flight cycle. In the case of range dependent, it will have both flight cycle as well as flight hours. And obviously, environmental deterioration is nothing but calendar. It's based on the year. So it will be number of years one has to inspect it. Obviously, accidental damage is whenever the accident occurs during the work around inspection, like a lightning strike, or you have a dent due to hailstorm, or when aircraft on the ground, some ground vehicle might have hit somewhere. So in that case, it has to be attended there and then. There's nothing. Only there's note down at what flight cycle or flight hour it has been happened. But usually for other type of fatigue damage, they can be expressed in terms of flight cycle or flight hour.
Sir, these all the flight cycles, it will automatically count by flight itself inside the Adobe, put it as a programming, or manually they will add it.
No, it will be there. Some conversion is there between flight hours and flight cycle.
Okay, but
Okay. See, flight cycle is nothing but not the individual flight cycle. You are not talking about peak and troughs that occurs.
okay.
One flight
One flight, it means from
from beginning,
taxi,
beginning
and
taxing,
yeah,
cruising, descending, and
land. That means
that is
it
a
will
one
count as
flight.
a one cycle. So
Uh,
these cycles are counted by automatically or manually. They will note it out.
no, I think it will be automated. Now all of your FDR is there and all things is there. See,
Yeah.
flight hours again. One is short distance. You are going say Bangalore to Chennai. It hardly
Yeah,
takes
that is
30
also
minutes.
one cycle.
Okay, that's
Sorry.
one cycle. But
Yeah,
duration is hardly half an hour.
yeah.
But another from Bangalore to San Francisco, 20
Mm,
hours.
yeah.
That's also one flight cycle. What
Mm.
is 20 hours?
Yeah, hours will be more, but this suppose 3,000, 30,000 cycle means every time entering is difficult.
Flight cycle, everything take up and landing.
Okay.
30,000 times it is
So
expected to
automatically,
occur.
maybe inside, automatically it will count.
Yeah, yes.
Yeah, okay.
Because FDR will be recording, no?
Yeah.
Taxing
FDR
all
is
the
recording this.
parameters.
Yeah.
So this is a process sheet. Again, it's not so available in openly. You can see that you have a viewing rating, then congestion rating. Put together is known as access rating. Along with access rating and size rating, then you have a practicality rating. And again, it depends on the lightning rating. So you have seen those 5 parameters. Then surface rating. Okay, please remember the congestion rating different, surface rating different. So you can have surface rating either dirty or clean, depending on the grease, sealant, and all. And again, it can be in exterior of aircraft, in shadow, because again, lightning depends. So these ratings are already decided and assigned by MSC3. It's a steering committee, so there will be so many members will be there. So based on their study and systematic study, they have given the rating. So based on that, finally you come with some rating. This rating is nothing but crack length. Okay. Once I show the example, the clarity will there. But this is the process sheet they use to arrive at the detectable crack length, which has been decided by MSC3, accepted by airlines, OEM, and all. So here example, the item involves the bottom skin lower surface between rib 1 to rib 12. You can imagine. So bottom surface, there will be so many ribs between the spar, between front spar to the rear spar. And obviously they will be having a countersunk head, which you have already defined. L visual is L vision. So it's not likely that crack may grow both directions simultaneously. If at all it grows simultaneously, but length may be different. That's why it has been given the two different visual, and left hand side may be different crack length and right hand side will be different crack length. And L hidden is nothing but the diameter of the countersunk head, and L0 is the diameter of the sign. These reverse. So this is thickness of the plate. So in that case, how to detect, use the detect, what should be the detectable crack length if at all using the GPI, then if not practicable, then you have to go to DVI, detailed visual inspection. So your visual is consists of visual 1 and visual 2. If it's a crack is going only one side, obviously visual 1 will be 0 or one of them will be 0. If both the sides are there, you have to add. That will get total visual. Then detectable is nothing but visual plus hidden. So yeah, the GVI inspection level is first as mentioned as a flow chart. They will try to attempt to use the simplest, less cost-effective downtime, which is GVI. And to start with, we have to calculate the basic, right? It is based on this rating. Okay. So based on the conditions, your viewing rating is good. That means when it is unrestricted as close as needed. So this is the viewing rating. Viewing rating is you have a poor, moderate, and good. So you are in this category good. Again, it depends on congestion rating. That components. This is also clear area since this is external skin area. It's a full, so it's a clear. So you can see viewing rating is good, congestion rating is clear. So you will have a number 5 is the number 5. So this 5 combination of congestion rating and viewing rating, your thing is coming 5. Combined is known as access rating. So again, access rating, it depends on the size. This is access rating 1, 2, 3, 4. So you are in this column 5, the extreme column 5. Then you have a size rating. It can be large area, then medium area, or large fitting, then medium fitting and small fitting. So based on that, it is size rating is 2 because it's a medium area. Okay, then size rating is, you can see that SSI 57 2012. So they have classified the wing 57 in the data chapter of the some section, maybe about 20, then dash 12. So they have classified certain area of the wing under one SSI because that's a big route to the tip is very large. So you cannot assign only one number. It has to be given at different items, number, serial number. So sizing it to, then your access rating 5, the combination of 2 and 5 will get practical rating as 3. Okay. So this is arrived by them. So what is the basis? Difficult to tell, but that is what they say. If this is the 5 and this is 2, then your return become 3. Now you have a practical rating 3. Then it depends on lightning rating. Now you are coming to the second sheet where you have a lightning rating. It can have a exterior things. You have different condition. Here is called lightning rating is exterior of aircraft in full daylight, because aircraft in the tarmac or runway next to hangar, it may be full daylight. You don't need any special light, and for that it can be visible. So lightning rating will come under that. Again, your surface rating is the area liable to be covered in sealant or not. The above 2 rating given condition rating is 2. Okay, condition rating has come to 1, 2, 3, 4, so it is coming 2. Practical rating 3 and condition rating 2. Basically, then it gives basis of 70 here. I think one of this point will give. So once you have the basic thing, you have to multiply gauge factor and gauge factor. So since stick thickness is 10.3 mm and non-edge crack, gauge, and for example it is a non-edge crack and thickness 10.3, your as for the assigned value, gauge factor is taken as a 1.5 and edge factor 1. So you multiply your visual, now it will become basic into gauge factor into multiply by edge factor. So which is nothing but 105 mm. Okay. So detectable will become 105 mm. Now you have to see whether it's practicable to use one. So next repeat inspection, you have to see whether it's practicable. Because if you detect only 105 and your critical crack length is, for example, 125, hardly there will be 20 mm left. Or even if you consider 25, 200 mm is the detectable crack length, so hardly there will be 95 mm. May not be practicable, depending the type of structure and criticality. Anyway, so this is what, based on the what we saw the previous slide, different conditions and all using the process set, we found the visual basic. Then next is visual. Then you are getting determination of hidden, because it is a countersunk. Okay, so in that case, hidden is given by L0 plus LC, which is 7.94. So for the example, it's given LC because you know the countersunk specification, so you know what is the LC. So for that type, it is 7.94, and I say LC is 5.68, diameter is L0. So you add it up, so it's become 13.62 mm. Now your total detectable crack length will be L visual plus L hidden. So that works out to be 118.62.
Sir, this crack length is too detectable crack length is at a very long, no, sir. It's very large.
Yeah,
It's very,
large. Yeah, that's a giving example. But they will attempt to use 10 means GBI. Some cases may be possible. Okay, I was telling the example other day.
okay.
If the flap or the wing is pierced with a very sharpened object during the walk around inspection, the technician cannot, because it's a short time is aircraft is landing, right, before going to the next
Yeah.
destination.
Okay.
So if fatal it happens, the detectable crack will 70 mm.
Oh, detectable crack length is 70 mm. Okay.
And they recommend it has to be used for, they cannot, NDT equipment means you have to put in a hangar, you should have the facility should be available. In situ is not possible because you have a short time available.
Okay,
But in that
less than
case,
70, if it is less than 70 mm,
70,
then
that's a, no, you cannot do anything because that fellow will be in the ground, and if it's a high wing or mid wing aircraft wing,
okay.
that fellow will not able to see it.
Ah,
Assuming that is wing is far up and GBI though, so it's 70 mm.
okay, okay.
So then they calculate for detectable crack length, and obviously this has to be repaired because the flap skin which will affect your lift and all.
Yeah,
They'll
yeah.
see whether it can go to the next test. Minimum it has to have a 50 mm before 50 flight hours or
Okay.
flight hours before
Okay.
it goes to the next airport where the facility is available to repair it.
Okay, okay.
They will not allow to go for next inspection interval. Okay, this is a very critical situation.
Okay, sir. Okay. Understood.
So this is the example it says where the crack is 118 is very large, right? You
Yeah,
can
yeah, it's
easily
very
check
large.
that.
Yes.
So what it says, since this GBI doesn't give an adequate inspection interval, the higher inspection, so it's not practicable, I mean feasible. So they have to go to next DET. Okay.
Okay.
Your now L basic needs to be redetermined, which involves the lightning rating and surface rating to be reselected. Other things remain same because the component wise is remain same.
Okay.
Only for DT, if you the silent features, you need to use concentrated light, and you have to remove the sealant and like that. Okay. If you
Okay.
go to DVI, so lightning rating is become concentrated lighting as required, and surface rating is clean area. Okay. Then the above two ratings give now condition rating 4. Instead of 5, it is giving now rating as a 4. Once you clean that and use concentrated lighting, your improvement scope clarity is there. So instead of earlier it was 5, it's become 4. Then practical rating become 3 and condition rating become 4. So which will give 22 mm is the basic. Now
Okay.
again, your gauge factor and edge factor will remain same because same 10.3 mm and non-edge crack. So you will get now 33. Now your detector will become 46. See, where is 118, 118 or 108? 118.62, right? Yeah, 108.62. Now it has become 46. Almost less than 50% of the what one could detected using general visual inspection. Okay, this is not required. Then I will stop here. We'll take a break. Then we'll go the overview of non-destructive testing.
Okay, sir. ஹலோ ஹலோ
இங்க இருக்கேன்.
வீட்டில் தான்